Oh, here he comes. And off we go. Crouch, and through the door, and round the fork, and under again. And oh, quick. And phew, I think we're okay. Hello, my fellow gnomes. Welcome back. So, starting where we left off in episode 11, and let's just drag our assets folder back into the workspace so we can take a look at them. And we've got our enemies over here. We actually got rid of this chef model and we swapped it out for this skeleton in the end. Let's drag him over here where we can see him. And we're going to add in our new enemy now, which is going to be sort of like the Seek monster from Doors. But again, we're going to do our own thing as we've done a little bit throughout this series. And I'm actually adding in something I made earlier, which is this bacon hair character, which I know it doesn't look too scary right now. But what we're going to do is we're going to animate his face later. We're not going to do the animations here in this video, but you can do animations however you like. We're going to be using the same method that we used for our skeleton, where we take that default script and we copy it over so it's a run context of client. If you haven't watched the previous video, then recommend doing so. But we've already got this bacon already set up with some animations. And if I come down here, we can see both of them are already animated. And here is our rather scary looking bacon hair. It looks a bit more scary now. So that's what we're going to have for our chasing dude. But we need some rooms for him to chase us down. So here's a few I made earlier. I'm just going to paste them in right now. Move them over here. So I've got two long corridors. And one of them I filled with furniture. And this is where we want to crouch and crawl underneath these as we go down. The other one is another long corridor, but it's just blank. And we're going to use this as like the initial trigger for starting the chase scene. And then finally, we've got these two rooms, which are little forks. So when you're going really fast and you turn left, oh no, dead end. You have to take the right fork in this one. And this is the opposite, but a left fork. So we're using all the same logic for our rooms as we've done previously. The only thing that I've added into this window corridor, if we go down, you can see I've added in a little part here called trigger. If I just turn off the transparency, you can see that big blue part. If we look at the orientation indicator, we can see it's actually facing forwards. Okay. And we've set that to fully transparent. It is anchored and the collisions are disabled on it. And that's what we're going to use to trigger the whole start of this monster chase sequence. But since we've added in these 4 new rooms to our game, we now need to go into room info and add that information. So server script service, go to room and room info. We can put this wherever we like, but I'm just going to paste that in here. So we've got crouch corridor, fork left, fork right, and window corridor, which is the name of each of these new models. Now I'm setting the crouch corridor's weight to 0 because I don't want that to spawn in randomly. The window corridor is actually, I don't mind if we just have this at some random point during the game. You might not want to, so you could set this to 0, but I'm going to set it to like a low number, like 0.2 or something. So there is actually a chance that it could spawn in randomly if it wants to. The forks, I'm fine with keeping those in, as I've gone pretty minimalistic with the whole decor of it. But if you wanted these to look more extreme and more spooky, so they're just for the chase scene, then obviously you'd set that weight to 0 for those. So then if we pop over to our server script, and last time we were playing about with the kitchen, we put that in at 1. Let's just put it down to 10, and then we can actually start to do the logic for our monster, which in our case is called Bacon. You can call this Seek if you like. And I want him to start at, I think, the second room, or we could do the first room even just for testing. And so let's just create a little variable for this. And we're going to say bacon start equals 1. And then we can say bacon start equals, and the first one we want is the window corridor, which is this room right here that I've made. So I want that to be the first one to spawn in, but then I don't want to have a random room next, because then I want to have this this crouch corridor, as I've named it. So in my server here, beneath that line, I'm going to say bacon start +1 and set that equal to crouch corridor. So let's just play and test that's working now. Oh, we have got a little problem there. We forgot to add in our comma. And since we're done with these assets, let's click and drag those back into replicated storage. So now if we go and play, let's see, first room is the corridor, perfect. And we can just make our way through it, no trouble. And then we're going to get to this crouch corridor. And I can't actually get through any of these objects, which is no good because we have no crouching in our game. So we've got no monster, but we haven't got any crouching either. Now, I'm not actually going to cover how to make the crawling stuff in this video, but last week I did make a standalone video all about how to make a crouch system. So in fact, I'm just got that already copied to my clipboard. So I'm going to go into starter character scripts and just paste it in. If you want to know how to make this script where I talk you through the whole creation of it, then go check out that video now. But otherwise, if you've already done that, then here we go. We have the script. And so now if I just click play and I hit the control key, I am now slowly crawling around on the floor, which means that when I get into that obstacle room, I can go over here and start to crawl through. Now, if you're wondering how I sometimes seem to like clip into some of the furniture, just so you know how this is set up, I've actually got an invisible wall. So in reality, the collisions look like this. And all of this furniture, I've disabled the collisions on. So I can move slightly into it. If I was to like drag it out, just so you can see, make it more obvious, there's no collisions on any of this furniture. It's just this little wall I've set up just to make the collisions a bit smoother for when we're moving through them. So now we just need to actually get a script for our new seek or bacon monster. I'll just call it bacon from now on. That makes it a bit more, or a bit less confusing rather. And we've actually got a script pretty similar for this. So if we go into our monsters, we've got the shadow. And I'm just going to duplicate the shadow script. I'm going to rename it bacon. And then if we go in and we'll rename all the references to shadow into bacon, like so. First off, we don't need this find players function anymore, so we can just go ahead and delete that. And we don't need to use lerp2 either, so we'll delete that because we can actually make use of our monster's humanoid instead, and we can use its move2 property. So we'll delete this line here, and instead I can say model.humanoid and use the move2 method. To start with, we need to go to the room's entrance.position. We'll wait until the humanoid has finished moving. And then we want to move through all of the waypoints, which is going to use the same logic again, except this time it's waypoints I.position. And then finally, we just need to move to the exit at the end. So get rid of this lerp and instead change this to exit. Then in the bacon.new script, make sure we're actually copying the right name. So in my enemies folder, I've called it bacon with a capital B. So change that line here. So that is bacon with a capital B. Now with the shadow, we wanted him to spawn a room back. We don't actually need to do that here. So we can get rid of this references to the previous number and the previous room. Instead, we're going to want to know what the current room is. So the current room is generated rooms number. And then just for testing, let's move our bacon to the current room.entrance.cframe. And then instead of generating it, putting in the previous number, we'll just send the current number. So that's some modifications. Now we've got this new bacon module. Let's make sure we're calling it from the server. So just below chef here, we can say bacon equals require, and we're going to get the script, which is, if we're in the server script, from the monster.bacon. So script.monster.bacon. Now, unlike our other monsters, which spawn in either as soon as the room loads, in the case of the chef, or as soon as a player enters the room, in the case of Shadow, we actually want this to spawn in when we get further down the corridor. And that's where that trigger part I showed you a moment ago, if I just move it back in a second, we see in window corridor, we have this part called trigger, and that's when we want it to activate. So let's drag this model back into the rooms, and I'm going to set up a little event, a bindable event. We're going to add this into the room. Let's call it chase sequence. Why not? And then within our room script, our room module, when we generate the new room down here, we have all our logic for spawning items. And then just below that, before we add in the new door, let's do a little check. We'll say if our specific room name is the window corridor, then we're going to listen in to that part, our trigger part being touched. New room.trigger.touched. Connect that into a function, which will give us the other part that has been hit. And then we can say script.chase sequence, and we can fire that bindable event. We're going to say true along with the current number of the room that we're inside. Now, we don't want this to keep firing every time people touch it. If there's multiple players in the game or just a single player moving through the part, that will cause multiple firings of this touched event. So we're going to actually save it to a little connection variable. Initially, it's going to be equal to nil. We can set the whole event function equals to it, and then we can disconnect it as soon as it is fired. Oh, let's get rid of that little asterisk. There we go. So this whole thing will only run the one time for each room. So that's us telling the script that, hey, we want to spawn in, we want to start this chase sequence, but we need to set up something to receive that. So let's go back into our main server script, and just below the player entered event, well, we can set up script.chase. Is it inside of this script? No, it's inside of the room, isn't it? So script.room.chase sequence .event, connect that into a function, and we have two parameters for this, whether we're turning it on or off, so we'll call that enabled, and then also the room number that it's happened in. So if it is enabled, then in that case we want to spawn our bacon. So bacon.new, and we need to provide the number, the generated rooms table, and the maximum amount of rooms he's traveling through, which we can set to 4, but set this to however many rooms you want him to move through. At the moment, I've only got these 2 specific ones set up, but maybe you want to have 3, 4, 5, 6, that's up to you. But we're going to have it as 4 right now. Now, one thing to keep in mind is in our bacon.new function, when we're moving the humanoid, we're using this move to finish, which is actually going to yield this whole thing. So when we call bacon.new, it's going to have to run all of this code line by line, yielding all the time. And so when we're here, we're not going to be able to do anything else until he's completed moving. So to avoid this, I'm going to put task.spawn, which is like kind of creating a new little thread for ourselves. And, hang on. Task.spawn function like so, and then we can enter our function call here, and so that can happen in the background while we do other things. Now we probably want to do some more logic down here, handling the players and such like, but for now let's just click play and check that our monster is actually spawning in correctly. So here we are, we go into the room, and as soon as we touch that trigger part, we should see, there we go, he has spawned in. We have actually got an error down here from our bacon script. It looks like we're still using some leftover code from Shadow. So if we just click it and we can go back to it, yeah, we're trying to play some skull sound. We don't have that anymore. We can just remove that. Although, in fact, what I might do is I might add in some sort of like footstep sounds instead. So I'll find my bacon model. I'm going to go to his humanoid root part, and I've got 2 new sounds in there. So I've got a monster scare and seek footsteps. That's the footsteps and the scare. There we go. So let's reference the primary part dot seek footsteps, and we can cause that to play instead. And in we go. Get back to our trigger point. We'll hear him coming this time. And, oh, here he's coming, run, run. Although actually he can't kill us, because if we wait for him, we haven't actually set up any kill mechanics, and he just gets stuck, which is kind of handy. So I can actually just continue on and leave him in the dust and escape. So if we want to get rid of, prevent him from getting stuck, we could do something really fancy and like make him crawl under the little spots or make him like destroy them, but we're just going to keep it simple. And so those crawl spaces, I'll just drag in the room back so we can see it again. These parts, all of these parts. So at the moment, if you click on any part, you can see the collision group is just default, and these are exactly the same, but I can click and I can type anything I want. So I'm going to call this player block. You can see I've already typed this in previously. Okay, so I've selected all of them. They're all selected as player block. And you need to do this for all of your crawlways too. So this one needs to make sure that all of these have a collision group of player block as well. And then we'll go into the model tab, enable the collision groups. You can see we've already got monster and player collision groups. We're going to add in one more that we call it, use the exact same name that we just typed, player block. Hit enter, and all we want to do is we want player blocks to only block the player. They don't need to have any collisions with other player blocks or other monsters, which means that the monster will be able to walk straight through this barrier as if it's not there. It's only going to be a barrier or block to the player. Let's just make sure that we've set up the collision groups correctly for our bacon. Oh, it doesn't look like we have anything. So what we need to do is just loop through everything in the enemy model, and we call get descendants. And we'll loop through everything and we'll check if we find anything which is a base part, then we set that collision group to be equal to monster. And while we're here, actually, let's set the primary part, and we're going to call set network owner, and we're going to set that to nil to ensure that the server always maintains ownership of this model. It will just help it move that bit more smoothly as it's navigating and running through the levels. So now this time when I spawn in the monster and we run and we duck behind this, our crawling is very slow, but we should see he can actually move through all of these obstacles, and it's no big deal. He can keep moving through all of the rooms. If you notice he gets stuck in any place, you might need to set up some new collision groups in every other rooms, but eventually he gets into the 4th room and he just ends right there. What I want to do next is spawn in some more rooms. So at the moment I have this window corridor and then I have the crouch corridor, but I either want to spawn in, remember I've got the fork left and the fork right. Now I could hard code it, so I could simply say +2 and I could make it fork left. But if people are going to be playing this game multiple times, we want to have some variations. They don't know to always go to the left. We want it to be like an equal probability of going left or right. So I'm going to actually create a table, and the first value in the table is going to be fork left, add in a comma, and then add fork right after it. And then I'm going to have another crouching section, so that'll be +3. And then finally, for +4, I'm going to have one final fork. So now that we've changed how the sort of specific rooms table works with adding some additional tables, let's go into our room function, and we're going to try and grab an item from rooms with specific room name, but of course that might be a table now. So let's just check if the type of specific room name, if that is equal to a table, then we want to get a random element from within it. So let's just reset the variable and we'll say now it's equal to a math.random of the total amount of elements within it. So this is going to give us a random number between the total amount, which is 2. So random between 1 and 2. So we either get the first or the second element, which will be fork left or fork right. So now let's play, and hopefully we should start to have all those 4 sections now. We're probably going to get outrun by the monster because we're moving really slowly. So here he comes. We've got the first section. We've got our crawling. And we navigate through that. And then we're going to fork. That's quite loud. He's thundering along, but we'll follow along behind him. And it looks like we've got a fork left. He's going to the left here. And a fork left. And then he's disappeared. And that's it. That is the end of the section. So that's all of our sections done now. Let's hit stop. I think we need to give our characters some higher speed in order to avoid bacon. So within our server script where we have this chase sequence event, let's handle the players now. So let's loop through every player for I player in, and we need to get game.players get players. And let's check if they have a player.character. Well, in fact, if they don't have a player.character, then we can probably ignore them. And then we want to get their humanoid, and I want to boost their walk speed up. So let's try, the default is 16 for this. So if it's enabled, then I'm going to set it to double that, so 32. Otherwise, keep it at the default of 16. And if it has been enabled, we're actually going to make sure that everyone is teleported to that trigger point. So we can get the room from generated rooms, the current number, and then it's the .trigger.cframe. The reason we're doing this is because if there's multiple players in the game, then whoever reaches that trigger first, they're going to then bring all the other players along with them, rather than ending up in some weird situation where one player is a few rooms maybe ahead of the others. They get there first, and then other players end up behind where the monster spawns, and that's just going to be a confusing mess. Now, something we need to adjust, if we're going to change the walk speed, then we also have our crouch sprint thing to take, crouch script to take consideration, because we have some hard-coded speed values in here. So just to help, I'm going to actually set an attribute for the humanoid, set attribute, and say, we'll call it speed boost, and we'll set that to true. So then in our crouch script, when we set the speed, we're going to check if the humanoid get attribute speed boost. If that is true, then we're going to say, and we'll use the speed crawling value, which is 5. Let's bump that up a bit. Let's set it to ×3. Otherwise, just go at the usual slow crawling speed. And then if they're walking, well, we don't want to get reset to 16. So again, speed boost and speed default ×2. Otherwise, the default speed again. So this means if we're just crawling at any point during the game, then we are going to move slowly. But hopefully now, when we're doing that chase sequence, we're actually going to be moving faster. So let's see. Here we go. We're moving fast. And we're faster when we're crawling, and this will give us a much better chance of outrunning the monster dude. And we've also got these keys which we don't want, so we should disable locks on any of the generated rooms too. That's an easy enough fix. So if I look at my rooms, well, it's not even possible for this to have a lock. There's no item spawn locations. Neither are there in this room. So the only places that it's possible for a lock to spawn is these ones with the cupboard. So it's just my fork left and fork right models. So inside of my room module, I'm just going to say else if specific room name equals fork left or fork right. Oh, that's a butchered spelling right there. Then we'll just manually override and say requires key equals false. We're not going to use one after all. Although thinking about it, this will be happening after we've spawned in a key. So let's just move this actually up. Cut that. Move that. There we go. Keep that as it was. And up here instead, if it does not equal this, so we use a little tilde key, and it does not equal fork right, then if it's not that, then we'll do it. There we go. So if it is fork left or fork right, then we're not even going to try and spawn in a key and make the door be locked. That will fix that. So now we just need to make our monster actually kill players. So I'm going to use run service, and just before we start the navigation, I can say run service.heartbeat, connect that into a function. And if for some reason at any point we don't have a primary part, then we want to exit out of this heartbeat loop. So actually let's set up a little connection, and then we can make the connection equal to this, and we can disconnect it and return out. So this would be if once the monster has finished moving through all of its navigation and we've destroyed it, then we don't want to keep checking for people to kill. Now, seeing as our monster isn't directly chasing the players themselves, but rather following that track through the course with the navigation waypoints, we can't just calculate the distance between us and the player. Instead, we want to calculate our distance to the exit position. So to help me do this, I'm going to create a variable called our current room number. Initially, that will be nil. And then within this navigation loop, we can update it every time. So that will be equal to I. So initially it'll be equal to 1, and then probably we're going to finish at 4, seeing as I'm doing this for, if you remember, 4 rooms. Well, technically 5, including the place where we start the trigger. So back into the bacon module. Now I have this current room number. We can do some calculations with it. If we don't have it yet, so we've not got a current room number, then we will just return and we'll come back on the next heartbeat loop when hopefully we have it and we've actually started our navigation. Once we have the room number, we can get the current room easy enough by going to generated rooms and indexing the current room number. So then we can work out our distance, our monster distance, to the exit point. So that would be our enemy model.primary part.position minus our current room.exit.position. Now obviously this isn't a perfect algorithm because we're not taking account of waypoints here, but this is good enough for our use case. So we get the dot magnitude of that. That tells us the distance between those two vectors. And then we want to compare this distance with that of all the players. So let's loop through all of them. Again, if there's not a character, then we will ignore it. We'll try and find the humanoid root part. If there's not a root, then we'll ignore it. We also want to look for the humanoid too. So let's just copy that line, rename this to humanoid, and we'll search for humanoid. And if there's not a root or there's not a humanoid, then again, we will exit out. And we also want to check people who are alive. So if the humanoid.health is less than or equal to 0, then we don't care again. So then continue on and end. So now we should only be looking at players that have characters and a root and a humanoid and they're still alive. But how do we know what room the player's character is inside of? Because we haven't got this current room number for the players. So let's go and create something. Inside of our door module, at the moment, open doors if the door is locked and all of these other conditions are met. But let's actually have another if condition down here. And we'll say if our door model actually is open. So if it's open, then in that case, if you're touching the door part, then we know that they have reached that door. So hit.parent, which will be their character. And we can set an attribute of, say, max door reached. And we can set that equal to the current number. Now, obviously, if they're going backwards, then we don't want to set them to a lower number than they currently have. So we should probably do a little comparison first of all, where let's say that current number is equal to get attribute max door reached. And if we have a current number and that current number is greater than whatever number door this is, then we don't need to care. So we'll just return. But otherwise, we will set that new max door reach value. And now that we have that, we can start calculating the position of the players inside of our bacon module. So the player max door is equal to whatever max door reached value they have. Now it's possible they might not have one set up, so if they don't have a value for this, then we're going to ignore them, and hopefully as soon as they move through the next door, they will then have a value. But if that player max door is less than our current room number, then in that case, they must be behind the monster, so we can just go ahead and kill them straight away. Humanoid.health equals 0. Now the other possibility is that the player max door might be greater than our current room number. So we're a whole room ahead of them, in which case doesn't really matter. So we'll just continue. But otherwise, else if we're in the same room as the monster, then let's check how close we are to the exit and compare that with the monster. So our player distance is going to be equal to and exactly the same calculation as this. We can just copy this one and paste it, but this time, instead of using the enemy model's primary part, we can use our root variable. There we go. And then let's compare the player distance with the monster distance. So if the monster distance is less than the player distance, then we can go ahead and kill them, because the monster's closer to the exit and therefore they're probably about next to them in terms of progressing through the room. And while we're cleaning up this bacon module, you might remember in our room module we had this chase sequence that we fired off. Well, once we've finished our navigation and we've destroyed the model, let's fire off that chase sequence again. So it'll be script.parent.chase sequence. Sorry, .room.chase sequence, and this time we'll set enabled to be false. We can keep the number in there or we can just remove it. It doesn't really matter. We're not going to use it, but that would just ensure that we actually set their walk speed back down to the default of 16. So let's give all of those things a try. We should get to our trigger point, and oh, here he comes, and he's coming for us. And we're going to try and get through here, and then we're just going to wait on the corner here. And once he gets closer to the exit than us, we should find, yep, we are dead. Cool. So let's go back into our bacon script. I think I also want to make him move a little bit faster as well, because he feels kind of slow. So we can set our walk speed, boost that up to 30 so he moves a little bit faster. And then we need to close the door, I think. So in our navigation, we're always trying to open the door. But let's just add a condition where we only try and open the door if I is less than max num. Like so. So now we're not going to try and open that final door as we're moving through it. But if the players got to it first, then we don't want to just disappear either. We want to lock that door behind them just as they get to the exit for that sort of dramatic finish like we see indoors. Now, if we remember, when we create each of these doors, we create this little bindable. It's called open event, and that's what we're firing here inside of our bacon. So it'd be nice if we could fire this, but actually get the door to shut. So we're going to say else, and we could fire this same event again, but this time we need some additional parameter to send. So we could say lock the door. Oh, I keep pressing my caps on. There we go, lock. And then if I go into my bindable event, we've got this request name, and then we could have an additional parameter called something like action, and then we can check. So if it's already locked, then we're going to want to open it. But else, if the door is currently open and the action type is equal to lock, then in that case, we're going to want to call a new function. And let's copy our door.open one. paste that down here, and we'll rename it door.lock. So we're going to do pretty much the same as opening, but just in reverse. So we'll set open to false, and then we'll rotate this instead of 100 degrees, we'll minus 100 degrees, so it goes backwards. I don't want to play the door opening noise. So if I go into find my door, we could remember inside of the door, we've got this open sound, I think we're playing. I've got an unlock sound too, but I'm just going to paste in, I've got this new close sound, and I'm going to play that close noise too for when it gets locked. I don't want to fire the player enter event anymore. But instead, I want to set an additional attribute. So we've got this open one, which is setting to true and false. But so that it can't be reopened, I'm going to set a new one called locked. And I'm going to set locked equals to true. And then I'll check the condition of this down when it gets triggered. Before we do anything else, let's just check if it's permalocked. So if the door model and we get the attribute locked, if that is true, then return out of here. Don't bother doing anything else. So now we've got this door.lock function. Let's just make sure we're actually calling it from inside of our bindable event, door.lock, and we need to send the door model and number just as before. To be honest, we don't even need this number anymore, so we could get rid of that. We're not actually using that here. But now we've done that, let's go and test. Trigger the monster, here he comes. He's moving a bit faster this time, we better get a move on. He might actually get killed here if we're not careful. There we go. Okay, we might need to tweak that run speed just a little bit. Okay, reset him to 26. And this time we're going to get my pro gamer skills on. And we should... Whoa, almost got caught out there. So once we go through the final fork and we wait for him, we should hopefully see the door gets... There we go. Closed behind him. We can't go back through. And neither can our monster. Pretty cool. It's not quite as dramatic as doors, but we can work on that. The next thing I want to take a look at, though, is actually when he spawns in. Because at the moment, we get down here and, yeah, we hear the sound, but it's not really got quite the same level of suspense. It'd be nice if we could have some custom camera effects and also not have him spawn in looking the other way, which is a bit silly. So first off, let's have a look at spawning him sort of facing in the right way, and maybe we'll have him sort of float up from the ground like he does indoors. So if I just get out the room just to show you what's happening at the moment, get my window corridor, and of course I spawn him using the position of the entrance, and if we look at the orientation indicator faces backwards, right? So we are spawning him using this position, hence he is facing the wrong way. We spawn him in entrance.cframe. So instead of spawning him just there, so let's create a value for the starting C-frame. Okay, so local entrance CF equals this current value that we're using. And then I'm also going to use an offset. And offset is to have him appear below the ground to start with. So that's going to be cframe.new, and let's try minus 14 on the y-axis, so he's going to be below, and then there's going to be a rotation as well, because we need to flip him around, and that's cframe.angles 0, and then we want to rotate him around 180, so math.rad to convert degrees into radians, 180 to flip him around on that y-axis, so he's facing the right way. So then we want to pivot him towards the entrance CF times the offset times the rotation. And hopefully when I now spawn him in, I'm not actually going to see anything because he's going to be beneath the floor. There we go. But if I move my camera, you can see he's trying to desperately move underneath the rooms, which is kind of interesting. So we should probably anchor him, first of all. Enemy model .priming part .anchored, set that to true. Retest again. And we should be able to hear him moving. but he is now perfectly beneath the entrance doorway, okay? And from this position, we want to tween him up so he slowly floats upwards. And then we can also see we've got an error now because we're trying to call the network ownership on an anchored part, which Roblox won't allow us to do. So let's sort of split this off into 2 blocks. Once we've added him into the workspace, let's play a little sound as well. So you'll see I've actually already added into my bacon, in my humanoid root part, I have this monster scare sound. And that's what we're going to play. So we can get the enemy model.primary part.monster scare, tell that to play, and then we're going to set up a tween using tween service, which it looks like we haven't actually got. So we'll go to the very top of our script, create a little variable for tween service, game get service tween service, and now we can create a new tween on our primary part. We want it to last, say, 2 seconds. We could add more styles here, but we'll just keep it simple, just for 2 seconds. And then we want his C frame to be equal to, instead of entrance CF by offset by rotation, we simply want to move him to entrance CF times rotation. So not using the offset this time. And actually this needs to be inside some curly brackets, like so. And once we've created our tween, there we go, all created, you can see the formatting properly. We just tell the tween to play, and then we'll say tween.completed. We will wait till it's finished, and then we'll start playing the footstep noises. We're going to set the network ownership, so we need to make sure he is unanchored. Set that to false, and then we can do the collision groups and start him moving. So let's watch this closely. And there we go, he floats upwards and eventually he's going to start moving towards us. There's a bit of a delay there. I think we might be able to improve that. Rather than waiting for the tween to finish before unanchoring him, let's try doing that before, actually. So we'll tell the tween to play, then we're going to set him to anchored equals false, which should be fine because we're going to be still manually adjusting his C-frame value. And that should hopefully mean that we're not going to miss that first move to call, which I think is what was happening there. So let's try and play now. Get back to the trigger point. And he comes up and he immediately starts running towards us. That's much smoother. And we're dead again. So looks like we've got our server side effects going. Now I just want to trigger something on the client so that I can react to the monster spawning in and do some stuff with the camera. So I'll go down to starter player scripts, add in a local script. I'm going to name this chase local. And in order to communicate between my bacon module script, which is on the server, and this local script, I'm going to need a remote event. So go into replicator storage to our events, and then I'm going to add in a new remote event. We'll name this trigger chase. So then in our chase local, we're going to need to get replicator storage, get the events, and get the trigger chase remote. And then we can react to this being fired. Trigger chase event dot on client event, connect that into a function like so. And we're going to send a C-frame value from the server over to the client. And then we're going to use that C-frame to do some stuff with our camera. So we probably want to get our camera, which is workspace.currentCamera. And if for some reason we have not been given a C-frame value, then we can probably assume that the chase event has actually been triggered to end. So we can do our cleanup here. But otherwise, we're going to want to send our camera type, set it to scriptable, which means that we're not going to be using the default camera that follows the player, but we're going to be setting it from the script here. And then we want to set the C frame of the camera to be equal to the C frame that we've just been given. We're going to want to lower the field of view to make it a little bit more cinematic. I'm going to put it down to 30. And I'm going to disable the camera subject as well. So camera subject, it should be the humanoid by default. We're going to set that to 0. And so then when we're cleaning up, we're going to want to set the field of view back to the default, which is 70, and return. So let's just go and connect to this from the server now. So before we even start any of the tweening, I'm actually going to fire off that event nice and early. So let's say replicate storage.events.trigger chase, and I'm going to fire all clients. And the C-frame value I'm going to send is I'm just going to send the entrance C-frame. So now when I hit that part, I'm going to be looking sort of into the spawn area, which isn't really what I want. So we've got to take that value and do some calculations with it rather than just blindly using that as our C-frame. So rather than placing our camera directly inside of that part, let's create a little offset. So like our starting position is going to be equal to that C-frame, but then I'm going to want to offset it by a new C-frame, 0 on the X, maybe a little slightly higher up. So we go +3 on the Y, and let's say 20 studs back. So we're actually looking at it a bit better. And now we're going to calculate the C-frame using the C-frame.lookAt method. We're going to start off starting position dot position, because we need to provide a vector 3 for this. And then where we want to look at. And we want to be looking at the C-frame. So now our camera should be spawning about sort of here-ish, looking at the doorway. So let's see, when we hit that trigger point. Oh, and hang on a minute, we have an error. We can see I've just set C-frame. I want to type C-frame.position because we need vector 3s, as I was just saying. So let's get down this corridor again. And there we go. That's quite nicely framed. But it doesn't switch back to us. It just kills us, which isn't ideal. So now we want to go back to our player. And if we remember, this tween of the monster rising upwards takes 2 seconds. So we should probably keep the camera there for 2 seconds. And then after that time is up, we want to switch back the camera to the player again. So the camera.camera type, we set to enum.cameratype.custom, which might sound strange that it's custom, but custom is just the name of the default one. Now, in order to set the camera subject, we need the player's humanoid. So let's make sure we're just sort of getting their character and everything. So character is going to equal game.players.localplayer.character. If for some reason we don't have a character, then we probably shouldn't be trying to do any of this anyway. So let's just return, exit, ignore all of this. But otherwise, let's get their humanoid and their humanoid root part, which we'll just set as root. So then we can set the camera subject back to the humanoid, and then the field of view, rather than setting it to the default of 70, I think to make it a little bit more dramatic to the chase sequence, we're going to set it higher up, so it's 100. It'll make it feel like we're moving that a little bit faster. Now, the problem we might get here is that our camera might actually be kind of facing the wrong way, and we want to make sure it's facing the direction we're traveling in. So let's just quickly work out our target, which is going to be the whatever orientation our route is in when we trigger this whole chase. And then we want to like offset, say, 30 studs ahead of ourselves. So 0, 0, minus 30. So then we know that the direction is simply our current route dot position minus our target dot position. We can set the camera.cframe equal to the target. And so that we can't move around during the time this cutscene is happening, let's anchor the route as well. So we'll set route.anchored equal to true. And then once we will finished, we will set it back to false again. Now I'll show you why I created this direction variable in a minute, but first let's just check it's working as we expect it to. So if we get here, we should see Yep, we've got the camera and then back to us, and we've got quite this high field of view now, which makes it feel like we're moving even faster, and everything is sort of like on a fisheye lens. That's pretty cool. We're also going to need to make sure that we disable this at the very end. So firing all clients here, make sure we copy that, and then at the very end, once we start doing all our cleanup, after we've ended the chase sequence for the server script, we're going to want to clean it up for all of the players too. And set that to 0. Because if it's set to 0, then we're just going to do the default and then exit out of there. Alternatively, if like a single player reaches there first, then we should probably listen for them entering into that final room. So inside our character appearance loaded on the server, let's say character, and we can get attribute change signal for the max door reached, connect that into a function, and then we can see which door they're at. So the maximum door reached will be equal to character get attribute and the max door reached. Now, if that value is greater than, in this case, our bacon start plus 4, because that is going to be the final one, then we know that they've finished. So we want to disable all of those effects. I think we're going to need replicate the storage here. It doesn't look like we've got it. So at the very top, we'll create a variable for that. And then we can call our event, can't we? So replicate the storage dot events dot trigger chase. And instead of firing all clients, fire the specific client, which is the player that has reached it. And we don't want to send any other data. That's just 0. So now if we're running, we will trigger the thing. He will rise up. It will switch back to our main camera, following at high speeds. And when we eventually get through this whole labyrinth and through the final door, it will reset back to the normal field of view. And he then gets locked in as well. There's one final effect I want to add. And sometimes when you're swapping around the player's camera, it can be a bit confusing. They don't realize they're in control of the character. And they might not realize they actually have to start moving. So what we're going to do is we're actually going to start manually moving the character for a couple of seconds, so that they're animated moving through that first door, rather than it being a bit of like a quick time event for them to actually realize that they're in control of the character. And so to do this, we're going to need access to run service in the top of our chase local script. Get run service. And then after we've waited 2 seconds, I'm going to use bind to render step. I'll call it force move. The value of like what priority I want to bind this at is enum.renderPriority.input.value. I want to make it +1. So it's got actual higher priority than the input from our own keyboard. So it's overriding all of the default stuff. I want to hook this into a function, which anything happening on run service, we have the delta time, which is the time between each frame. Let me just zoom out so you can see that whole thing. Now I want to keep track of how many frames we've ran for. So if we have our duration variable, set that to 0 initially, and then we can add to the duration each time using delta time. And I'm also going to move the humanoid using the humanoid move function, and I'm going to move it using that direction variable I created. And then if at any time, so if our duration is greater than 1, so in which case, we only want it to run for a single second, or let's see if we've already reached our target. So target.position minus root.position. If the magnitude of that is less than 1, then we want to return, but we also want to unbind this whole thing so it doesn't keep looping. So in order to do that, we just say run surface unbind from render step, and we use that same name, the force move. So if I now move to that trigger point and I take my finger off the keyboard, so I'm not pressing anything, my character will start moving in completely the wrong direction. Here we are. So I've said For my direction, I just need to swap these two values around. Let's make it so it's target.position minus our root.position. Whoa, here he comes, and we start moving through that first door, and then I stop moving here. And it just gives the player a little bit more time to react. Sort of shows them, yes, you're in a chase sequence, and that's what's expected of you. We might want to play some kind of groovy music as well, just to sort of set the vibe. So I can just paste in this track, chase, into my chase local script. If we're cleaning up, then we're going to want to make sure script.chase is stopped, but otherwise we will play it as soon as we start messing with the camera. We can play it. We also want to stop it if the humanoid dies, so we could set a little connection up here. Local connection equals humanoid dot died. Connect that into a function. Immediately disconnect it so that we're not calling this multiple times or anything, and then make sure, oh, we need to do this on a new line like so, because that's out of scope. Just create it like that, and then we will stop that sound. So now we probably have something a little bit more exciting. Moving along, going first person. Whoa, here he comes. And off we go. Crouch, and through the door, and round the fork, and under again. And oh, quick. And phew, I think we're okay. There we go. So that is our chase sequence. Hope you like it, guys. I think that's not bad. That's pretty fun. Hopefully that helps you with getting your own game set up and making your own little chase sequences. We're almost done with this Doors game, guys. This has been a very long video, and it's been a very long running series. But thank you very much for watching. We've got a few more episodes to crank out. So until then, I'll see you in the next episode. Goodbye!